Hello and welcome to the JILBOTIcs Classroom. I am Olunlade Joshua, and today we are going to be taking digital and analog signals. What is the difference between digital and analog signals, and how do they relate to Arduino and what we are doing? Before I move on, let me quickly say that this part of the course was prepared by my colleague Ojo Emmanuel and is actually supposed to present it. However, something important came up and I had to step in for him. So now let's get to it. What is a digital signal? Before we get to what a digital signal is, usually a computer only knows digital signals, 1 or 0. So for our knowledge of Arduino, let us just simply take it that a digital signal is a value 1 or 0. That is either high or low. So a digital signal can only be 1 or 0, high or low, true or false, on or off. So it can be either of two values really, a digital signal, high or low, which is equivalent to 1 or 0 on the computer. Now let me bring in a diagram to help us understand this. You can see here we have 0 and here we have 1. So now a digital signal is either 0 or 1. It's either 0 or 1. It cannot be in between this line. It is either 0 or 1 at all times. It is either 0 or 1. There is nothing like in between with digital signals. So it cannot be a range of values. A button is an example of a device that gives out a digital signal. Now, what are analog signals? Before we take in what analog signals are, let me quickly make this statement. Our world is mostly analog in nature. We usually perceive in ranges. For example, the intensity of light in the room you are in right now is in a range. What do I mean? Well, when you are outside during a very sunny day, it's brighter and you cannot even look up, but you can still look at your computer screen or your phone screen because the brightness is in a range, light is in a range. If you notice on our phones nowadays, there is a bar for you to increase or reduce the brightness because our world is in a range, our perception is in a range. Temperature is also in a range. It is also an example of a signal that is in a range. So analog signals really exist in ranges. For Arduino, analog signals will display in a range between 0 and 1023. A photoresistor or an LDR gives out analog input. Same with a variable resistor or a potentiometer. Now let me bring in a diagram to stimulate our understanding. Look at 0, where 0 is, and look at 1. So on your Arduino, I believe that you now know that, okay, let me say it like this. Anytime you are connecting any circuit, you usually use ground, right? And then 5 volts, is that correct? Now look at anywhere you connect ground to as 0 and look at 5 volts. For Arduino, for the Arduino logic circuit, 0 volts is ground and 5 volts is your I or 1. Notice in some videos ago when we asked the LED to switch on, we told it to go to a state that is high, is that correct, with our code? So we type digital right into brackets LED, high. Are you still following me? Yes, I hope. Okay, so now this 0 is low. Sorry, this 0 is low and this 1 is high on your Arduino. So now analog signals exist in ranges. And what do I mean? Look at this line. So you will notice that for the other one, for the digital signal, all these broken lines did not exist. But for an analog signal, the Arduino has been, how do I put it? It has been gridded in such a way that you can get a value from 0 to 1023. It's just like dividing this 0 to 1 to small ranges. So you can get 0, you can get 1, you can get 2, you can get 3, you can get 4, you can get 5, up to 1023. And you wonder that, but this is 1. Yes, this is 1, but the range of the value that you will get with the analog read function, that is what gives you from 0 to 1023. So I'm trying to explain so that you can understand. So this is the main difference between analog and digital signals. You see that it is very clear and there is nothing too ambiguous about it. As you move on in your microcontroller life or Arduino life, you will use many digital inputs and outputs and many analog inputs and outputs. Thank you for watching this video. I am Olunlade Joshua. I hope this video has helped you, and if you have any questions, please ask on the classroom platform provided for you by JILBOTIcs. Bye for now.